Okay, so we're going to look at some examples. So we were given expected value of x and standard deviation of x, and then we were given expected and standard deviation of y. So if we wanted to find the mean and standard deviation of 3x, so we're going to use this as multiplying by a constant. So the expected value is just going to be 3 times the expected value of x. That's how we deal with it when we're dealing with a scalar. So 3 times 11 is 22, or 33. Okay. So for standard deviation, we're multiplying by a scalar. Acts the same way. 3 times standard deviation of x. And so 3 times 9 is 27. Okay. Easy enough. All right, so the second one, we are subtracting a constant. So expected value, when we're subtracting a constant, is just the original expected value minus 15, or minus that same constant. So 24 minus 15 is 9. Okay. However, for standard deviation, our rule was that the standard deviation doesn't change when all we're doing is add or subtracting a constant. So this just is going to stay standard deviation of y. It's not going to change, so it's just going to stay at 5. Okay, these next two are looking at what happens when we add or subtract two random variables. So x plus y, the expected value is just going to be e of x plus e of y, which is 11 plus 24, so 35. So for the expected value of x plus y, all we do is add e of x and e of y. Expected value pretty much always does what you would expect it to. Yeah, I went there. So standard deviation of x plus y. Well, for this one, we can't just do standard deviation of x plus standard deviation of y. We would have to think of it as find the variance and then take the square root of it, or we can just use our formula, which was standard deviation of x squared plus standard deviation of y squared. Okay, so in this case, square root of 9 squared plus 5 squared, which is square root of 106, or about 10.3. Okay. One way to think of it would be to do the variance first, but for that I would need to know what the variances are. So standard deviation of x is 9, variance of x is 9 squared, or 81, variance of y, is 5 squared, or 25. So what we could do is we could say, well, what's the variance of x plus y? Well, that would be the variance of x plus the variance of y. So 81 plus 25, which is 103. And then the standard deviation would be the square root of that, which is where we got 10.3. So 106. Sorry, didn't add correctly. All right, so x minus y. Well, x minus y for expected value is pretty much just going to be exactly what you would expect. So e of x minus e of y, which is 11 minus 24, which is negative 13. Negative numbers are okay. We don't know what these probability models are representing, so it's okay to have a negative number. Sometimes we get negative numbers, and that's okay. So we're good. And then for standard deviation, what we need to remember is that regardless of if we are adding or subtracting, we will always add in the formula. So since I already did that with part C, I should know that this is going to come out to exactly the same thing, because I'm still going to add when I use the formula. So it'll end up being standard deviation of x squared plus standard deviation of y squared, which is what we already did and got 10.3. So there's that. I'm going to stop there for a second.